Sound test 1, 2, 3, 4, 5. Hello, everybody. I will solve some of those problems. I hope that today everything is okay with titles. Hard Codeforces live coding. Okay, good. As the title suggests, I will do only difficult problems today. Let's have some timer. Wait. So I will start in 5 minutes. Actually, 3 minutes, let's say. Until then, there's some time to ask me questions if you have any. Hi OG boys, hi Asterisk. How am I doing? It's fine. I'm busy the last few days because I have my normal responsibilities like a job. Plus also I do a lot of streaming and absolving. Even today in the morning I spent maybe an hour and a half on problem solving. So I understand already the solution, 2 solutions for F, and I want to implement one of them. This other problem, colorful tree, again, I already solved, so I will just go through it quickly at the beginning of this stream to summarize the solution for you. I tried Codeforces scoreboard. I've read the other problem, but seemed difficult. Where do I work? I work part-time in a high school, just teaching computer science, and also I work with companies like with Huawei. I work with Huawei and I do workshops for their interns. I help them with organizing competitions. So I'm this B2B employee. How important is absolving? Extremely important. It's the most important thing. During a contest, you will mainly solve problems that you already can solve. So there won't be, if you want real progress, you need to absolve problems. You need to solve after the competition things that you couldn't solve during a contest. And in particular, unless you're extremely high level, it's okay to look at the tutorial after some time of being stuck, because you will learn new tricks. I reached 2000 just by absolving. I think you needed to participate as well. So just by absolving doesn't work here. And for everybody else, absolving means solving after the contest. It's a Russian phrase, I believe. Okay, time's up. So let's go. First, I will talk about color for tree again because I solved it today in the morning. So I will maybe show this code later. I'm setting something up. Okay, done. Cool. Problem G, color for tree again from type Codeforces. When I went through those problems, I got up to F. E and F were not that easy, but the G was an easy problem. And here's the problem statement. You're given a tree and also every edge has some color. And you're interested in, that was a bad choice. You're interested in colors that form a path. So if there is an extra edge, let's say from 6 here to node 9, then green color would be not available. We're only interested in colors that create a connected component that forms a path if we only look at this color. Let's say that we are given such a tree. We see here one green path, one blue path, and one yellow path. Initially, all the nodes are available, and there are operations of blocking a node and blocking another node. Also, there is an operation of unblocking a node. After every operation, we need to say what is the color with the longest path, and nothing there can be blocked. Right now, the only available color is green, and it has a path of length 2, let's say. Yellow is not available. It's not that we can use this path from 4 to 6. We need to choose all edges of some color. So they say there needs to be a path consisting of edges of color C, and all edges of this color need to belong to the path. We cannot not include something. So right now colors yellow and blue are unavailable. Color green is available and its length would be the answer. Also, every edge has a weight, it has a length, but it doesn't matter. We can think about it as unit lengths. And we need to handle unblocking a node and blocking a node, and after every change we need to say what is the maximum length of something of one color. So obviously when we change state of a node, it will unlock or lock some colors, and the brute force would be to iterate all colors that are affected. So if you have some node, call it A, and it has a bunch of edges. For colors of all those edges, you can update and you can tell them, after blocking A, you can tell them, hey, you become unavailable, or you can increase their number of bad occurrences, bad nodes by 1. So for all those colors, we would increase their bad count. So for every color, for every edge going out of A, we would say bad count of that color plus plus. Then for every color, we would this way maintain the number of bad things for that color, and separately we can store a set or multiset, the best lengths, and while updating the bad count, if it becomes 0 or if it becomes 1, we erase or insert something to this global multiset. But this solution is slow because the number of neighbors of A can be big. You cannot iterate all the neighbors, and there is a trick for that. First, I thought that we should use centroid decomposition here, and yes, it is possible, but it will be a lot of coding. But it turns out that here, for all those colors of those edges, they create a group of one kind, because they all meet here. If we look at the previous slide, let's notice that blue path and green path, they are kind of the same, meaning they meet here in their LCA, let's say. And only one color, that's yellow here, is different in any way, because it goes up. So in general, when something changes for a node, we say that there might be a lot of paths that have LCA here, and I need to, of course, update them, but then there can be only one path that I need to update in a different way, because it looks like this. And all those paths with LCA here, in a node that I'm changing, I will treat in constant time, maybe, if possible. So in this node, in every node, I will store information with, again, a multiset about all the paths that have LCA here. I will keep here multiset of longs of lengths of paths that have LCA here, and if we ignore this node, they are good, meaning they are not blocked in any way. So if some path, like this yellow, if all the remaining nodes belonging to this yellow path, they are okay, they are not blocked, then the length of yellow path should belong here in this multiset. This multiset exists for every node. The sum of their sizes is linear. Then there's this top node. So whenever there is a change, let's notice that there is only one, at most one, path that goes up from this color, and it will have some LCA at the top, like here. And when we have red update, in the red node we change its state between blocked and unblocked, then this is LCA for which something will change as well. Multiset of that white LCA at the top will change. But that's a single change that we can do in logarithmic time. So the structures, the things that I maintain is this. For every color, I maintain bud count, and this excludes LCA. So except LCA. Because there can be thousands of colors that I need to update when their LCA changes. So no, if there is a path with 10 nodes, this thing needs to be from 0 to 9, because LCA is treated separately. Also, for every node, I have multiset of lengths of paths that have LCA here, and they are good except for this node, possibly. So multiset of lengths of paths with LCA here, such that bud count excluding LCA is equal to 0. For every node I have that multiset. And also I have one global multiset. And every node, if it's unblocked, it should give its biggest value to this global multiset. And that all can be combined and it just works. So when there is a change of this node, if it becomes like it changes between unblocked and blocked, so possibly its own multiset, its biggest value, should be inserted or erased from the global multiset, because this node now is available or not. And also I look at edge from this node that is being changed to its parent, here it's color white. I look at what is the LCA of white, what is the topmost node of white, and for that one I change its multiset, because for the white color the bud count changes. For example, if let's say there was here a node and it was available, let's say there was here a blue path, also a green path. Colors actually should be only for edges. Also this node is now blocked. And there is also this extra white color. Then what happens when this node gets blocked? Well, a moment ago, bud of blue was 0, bud of green was 1. Remember, bud is the number of blocked nodes of this color, except for LCA. LCA doesn't change. White also has its own bud. Let's say a moment ago, right now, for white, bud is equal to 0. Only green got some bud inside. And now, let's say that this changes. So what happens is this. In the multiset of this node, a moment ago, the only thing existing was length of blue path, because blue path is good. This doesn't have any blocked things. So there was a length here, let's call it 4, and this is the only thing that was in multiset for this node. And now, when this thing gets blocked, I don't change this multiset. This is still correct, because this is set of lengths of paths that have LCA here, and they don't have other blocked things. Also, this thing doesn't change, and this thing doesn't change, because it would be very slow to update those. So this multiset doesn't change, but what changes is this. Only if this node is not blocked, then this thing should be sent to global multiset, global set of available things. And now, a moment ago, this multiset contained a 4. It also contained length of white. Let's say length of white was 5. This was the global multiset. So this was from every node, I want to get the longest path with LCA there, such that this path is good. Now, because this thing gets blocked, this 4, we should be erased from the global set, but it's still here. Also, I'm looking from this blocked cell, I look at the color to the parent, I see that this color is white. I look at the LCA, I update color of white, white from 0 to 1, because now white path has one blocked cell, not including the LCA. And then for this thing at the top, the set will change. A moment ago, this set was, let's say, 5, and now I just erase it. Because right now there isn't any path with LCA here, and such that this path is not blocked at all. So also now maximum from this thing should be sent to the global set, which is 0, and this 5 gets erased, but it gets erased in a different way than this 4. Right now global set is empty, this set is 4, this set is empty. This set is 4 because this node knows that there is a path that goes through here with length of 4, and it's good except for this place. And later on, if ever this node gets unblocked, then this 4 will get back to the global set. So that's the solution. And the code is here. I have some helper DFS, but the most important part will be this. There is global multiset. I will skip the initialization. And now what do we have? Some colors are invalid because they don't form a path. But I'm changing state of node A. I look at color to the parent, and if this is valid color, so it was white path in our drawing a moment ago, I change the number of the bat count for this color, +1 or -1. Some assert. I like asserts because if I make a mistake, it will clearly tell me in what line there is a mistake. I find the topmost node, the top node of that thing. I pre-computed that with DFS. I look at multiset saved for that node, for that topmost node, and a single value there can be changed. So if that top thing is not blocked right now, so it sends some information to the global set, also if this set is not empty, then I erase that. It means if this node a moment ago was sending message 5 should be in global set because it's available, now I need to erase that 5 because we got something unavailable. So we erase. If bat is equal to C, it means that the bat count was a moment ago 1 and now it's 0. So we insert something. And that's, where do I insert? Color C. What is color C? Oh, that white color. So if 0, then at multiset of that thing I insert something. So that's a case of saying that this thing was blocked, now it's not. I'm unlocking that. And if white path because of that is available, now I'm inserting 5 back to this multiset and possibly back to this global multiset. If bat equals 1 and it was 0, then the other way around, I erase. When you use multiset, you need to carefully erase. And possibly I insert back to global. inserting from local for node set of possibilities to global happens only if this node is not blocked, because a local multiset contains information about all the paths with LCA here, and they don't care if LCA is blocked or not. So that's the logic. You can read the code after finding it in my submissions. If there are many elements in a local multiset in a specific node and that node gets blocked, then wouldn't a lot of updates need to happen in global multiset? No, because local thing sends to global only one thing. If there is some node with a lot of paths, like that, then it indeed contains in its multiset a lot of values, like 5, 7, 9, but only 9 is in global set. Global. This is 9, and maybe something else from other things. So when there is now a change of blocking this multiset I don't touch at all, and I'm only sending information. I'm aware that 9 was in global set, erase 9. And that's common. So this trick at looking of parents is one well-known trick. Another one, and I would say this is similar, is something like that. Like combination of segment tree and sets if you want to like practice an educational problem. Let's say that okay, consider this problem. There are n points, xi, yi, and you need to handle online updates or queries that are find topmost point, meaning highest y coordinate, with x lower with xi smaller or equal than something. Let's say something given to us. This is given in the query, and erase it. This is a well-known problem. Let's say that everything is up. If everything is up to billion, then you will need to use coordinate compression here first. So n is up to 200,000, xi, yi up to 1 billion. Step 1 is coordinate compression on x, so that it would get down to 200,000. And then build, this is step 2, build segment tree on x, and for every x coordinate there might be multiple y coordinates, and one solution is this: for every x, keep a multiset of y coordinates existing there. So if there is a point 35, there is also a point 39. Then you can have a multiset with 5 and 9. And in that segment tree, where for every x you want to know the highest y, you can insert the top value. When something erases it, you need to look up in a set what was the top value and send it to a segment tree removed from a set. So maybe step 2, create array of sets, of multi-sets if points can be repeated. For every x, the list of y's sorted by y, and build a segment tree for this, where for every x it should know the highest y, and then in such a segment tree, in a range of x's, you can ask for highest y. Does coordinate compressions only store relative position of x? Yes, exactly that. That's coordinate compression. And on the level of solving problems like this G from Codeforces, you need to know such a trick. Like, this problem should be easy for you. And I think implementing this is a good prerequisite to then implementing this thing from a graph, even though the difficulty is similar. And we don't have any segment tree here. That's not this thing on the left. All right. If you have any other questions, do ask. And then we are done with colorful tree again. Now I will move to thing that I tried doing with DP, but it was too slow and incorrect. Maybe I had some bug. These are problems with so specific tricks. The whole competitive programming is a set of specific tricks, right? So yes, I saw that many times, a lot of small things. G sound easy? It wasn't difficult. F was more difficult, but it's a different contest. No, this one, Coxia and sequence. During a contest, I tried doing some kind of DP on bits. But now I, first of all, understand the intended solution. Second, I understand one more solution. Radeusz explained his solution to me, and I think it's easier to come up with. In this problem, we are given 3 values. Some of them are huge, up to 2 to the 60th power. We need to count sequences of length n, such that the sum of values is x, bitwise OR of values is y. And we, oh, sorry, not count sequences. We need to compute bitwise XOR of all such sequences. Bitwise OR boils down to applying inclusion-exclusion principle during a contest. While I tried to solve it, I realized that, but in my solution it didn't help at all, so I just included it as a dimension of DP. But more important thing is combining summing elements with XORing. And first I will walk you through the intended solution. Didn't want to click that. Oh, and while I remember, if you want to help me, you can, after I'm done with any stream, you can go to YouTube, and in the comments you can write timestamps for problems, unless somebody else already did that, because now I have like 5 past streams from the last few days, and I would prefer not to spend extra time. It's not that big of a deal, but still I would prefer somebody else to do it. So if you see a stream, a recent stream with no timestamps, and nobody else yet in comments wrote down timestamps, please do it. Thank you. Okay, F. Okay, so what I did realize is this. If a of 1 is not equal to a of 2, then, like, you know, a of 1 is 5, a of 2 is 3, and then there are other elements, then also a valid solution is swapping those 2 elements. So like that we can explain that we should only count sequences where a1 is equal to a2. And we can do a lot of observations like that, and a proper combination of such observations gives us a valid solution. But first of all, inclusion-exclusion principle. We want the bitwise OR of all the numbers to be equal to y. Instead of that, step 1 is to use inclusion-exclusion. And then this increases the time complexity by 2 at power 20, but because of that, we have a condition that every AI needs to be included. What's the character for that? Also, no, this doesn't change. This is in LaTeX for set inside other set. Subset. I'm just copying a character. Here you go. For sets, this means this is a subset of y, because y tells us what bits are allowed, because we want numbers to have bitwise OR equal to that. And by inclusion exclusion, we change the requirement that it's equal to just belongs to. So every AI in binary form needs to be a subset of Y. Okay, now second thing, because we sum up bitwise XOR, I can focus on a single number. So first try would be iterate every possible A1, and for every value of A1, we can just count sequences from A2 to AN, and if there is odd number of them, then XOR A1 to the answer. Because if for A1 there is, let's say, 50 ways, let's say that we choose A1 is equal to 7. If there are 50 ways to finish the sequence, then that's even, and 50 times we will get 7 XOR to the answer. And so that cancels out. We want to here check if there is an odd number of ways to finish. If so, answer XOR equal with 1. But we shouldn't iterate all A1s, but we can look at every bit separately. Because A1 consists of a lot of bits and they are independent. When we want to know bitwise XOR of the answer, we can look at position 0, position 1, and so on. So to make it faster, for every bit, and 0 to 19, and so consider A of I bit to be 1. This is simplified notation, meaning the bit of I of A1, we just focus on one element, is 1. And now we need to check if there is odd number of ways to finish. Meaning choose all the other bits of A1 and also all the other numbers. What now? We need to find this, where the first element is a little bit special. And there is that condition. Let's go full screen with that. Now this is sum over such possibilities that the sum of AN equals X. And here comes a trick, and that's a crazy trick from editorial. We are computing things modulo 2, right? Because of that. We want to add to the answer, we will add this bit if there is odd number of ways, so we can just compute things modulo 2. That always happens when the statement says compute the answer modulo 2. Here we actually derived that, but whatever. So here everything I need to do mod 2. And that changes things a lot. Because I can consider all the sequences AI, and I can multiply modulo 2 Boolean values like that. Boolean value, meaning AI belongs to Y, times Boolean value for, A2 belongs, and so on. This is the product for every I. This means this is product just like this is the sum. Even in C++, but also in math, just if this you treat as 0 or 1, you can multiply those things, and only if all of them are 1, then this will get counted. And you sum this up, modulo 2. And now comes a crazy trick. This thing, modulo 2, is equal, or well, rather, yeah, this thing. This thing, modulo 2, that's equal to Y choose AI. And this identity has, for example, a name Lucas theorem. I was aware of that, but I very rarely remember to use it during contests. And usually the Lucas theorem actually provides a transition the other way around. I mean, if you see binomial coefficient, you might think about Lucas theorem, because Lucas theorem says if you have a binomial coefficient, you can write it down as the product of some things. Wait, I'm saying something stupid. No, it's okay. So as a product of things, if you break it down into bits, and like that you can prove that this is equivalent to that. But for me, it's crazy to this thing write down in form of a product where, you know, there isn't any product mentioned here, and then to say this turns out to be binomial coefficient. I find this to be extremely difficult. Like if this was the only solution, for me this should be the most difficult problem in Division 1 contest. So this thing we can replace as y choose AI modulo 2, which is just 0 or 1. We don't care about the value of this, we care about its parity. So if y is, let's say, 100, AI is 37. I don't care what is 100 modulo, what is 100 choose 37. I care only if this is even or odd, because that turns out to be equivalent to checking if AI binarily belongs to y, if this is a subset. And now, if you look at this, now from combinatorics we can argument how this is equal to something easier. Because if you have, I don't know, y possible elements, and from them you want to choose, I don't know, some value a1 equal to 0 or 1 or and so on up to y. And here you have another y elements, and also you can from them choose a2 equal to 0 or 1 and so on. Then if you multiply how many ways you have to choose a1 elements from here times a2 elements from there, then basically you can choose whatever you want. So this is simply choosing from 2y elements, choosing like any subset. That would be just 2 at power that. But also we have a requirement, a1 plus a2 equals x. Problem being, I don't have that command, but we're solving this, Coxian sequence. Now we want a1 plus a2 to be x, so it's like from now 2y elements we choose x elements, and that's 2y choose x. So here, back to here, this, if we want to multiply it by all possibilities of having a sequence AI, that is simply, and here we have sum of n elements, and y choose x. Because we n times from y elements we choose any subset. So in total from ny possibilities we choose x. One thing was that we fixed a single bit of a1. So actually there was some requirement about this guy. I think we can do this. Subtract 2 at power whatever that is, because now a1 we want it to for sure include value, let's say 4. No, that's wrong. I wanted to say this, but it's, I think, incorrect. But it should be almost correct. Like temporarily from a1 I subtract this bit, and then I add it back. Also from x I would subtract it. But it doesn't guarantee that there will be a 1. There could be a 1 before. I think that from y I should also exclude it. We're a few characters away in this slide from the solution, and once we are, it will be 5 minutes to implement it. Because the solution is for loop of size 2 at power 20 times for loop of size 20, and then just adding to the answer this formula multiplied by stuff from the for loops. Maybe this bit should be just straight excluded from y. Okay. The first y will be special. I think that it will be y minus 2 at power b, choose a1, multiplied by y, choose a2, multiplied by this, and so on. So it will be just ny minus 2 at power b, choose x minus 2 at power b. I think that's it. I will now check in the editorial if maybe not here. Yep, that works. Wait, y prime. This y prime. Oh, that's just updated y. So this is my y. Okay. Yeah, that works. So that's it. Now I will move this to a side. I mean, just this formula I need to retype, also those things. This is f, but that's another f. I can just erase it. Do we have test cases? No. NXY. We'll have some big binomial coefficients to compute, or their parity rather. But anyway, first, inclusion, exclusion. For all the subsets of y, if if mask is submask of y, this will tell me if I should use -1 or +1 in inclusion exclusion. Then for every bit, and there are 20 of them. Why is that 20? Because that's y. Is that okay? So if y, or even mask, I guess. But for mask equals 0, nothing will happen, and that's fine. I want to say if this bit is on, but because otherwise it's not allowed, we consider a of 1 or a of 0 of bit to be 1. Now we need to check this guy. First, I'm tempted to implement that just with brute force. Maybe not. Now x is huge, this is huge. I need to compute this modulo 2, so I think we need to use Lucas' theorem to do it. Only used inclusion-exclusion when working with primes? That's strange. Inclusion-exclusion doesn't have that much to do with primes. I don't know what's... Yeah, I'm surprised by this. Okay. Ny is small enough? Yes, it is. And now if A choose B modulo 2, then answer is int. Yes. Increase by 2 at power b multiplied by, if diff is odd, then -1, otherwise +1. And okay, let's just use Lucas' theorem. I should remember it by now. I need to check. Oh, if one is subset of the other, of course. So return whether A and B is equal to B. That's Lucas' theorem, modulo 2. Zero. Not a good sign. 0 and 0. Also, I want diff. Y is 3, so we have subsets 1, 2, 3. Those have diff equals 1, diff equals 0, that's good. What is B? B is the bit. In this case there are two possibilities, cool. And now we have from some formula 8 choose 4, 7 choose 3. This is a subset, this is not a subset. Let's verify that. This should be odd and this should be even. Yes, that's correct. So modulo 2 only those matter, and they have a different diff, so they will cancel out. One of them shouldn't. Now which one? We have 3 elements. That's a lot of elements to consider. If sum equal to 5, I iterated all the triples with sum equal to x. And what should I do with them? Okay, 21, but what I wanted is to check something with the XOR. Also, if n is even, then maybe I should just print 0. Oh, because at the end just answer gets multiplied by n. So I think that, well, whatever. So if this is 0, then just print 0. Otherwise, like the first element is like any of n elements, there's odd number of them. Cool. Now there is this, and I want to say if, let's say, this plus that plus this we will check how many have this bit on. No, just if this is odd, count plus plus in all of them. Well, of course, if you add up 3 numbers, if you add 3 numbers and the sum should be odd, then there is odd number of odd numbers. I didn't need this to tell me. So 21 is odd. This corresponds to mask 3, B0, and this turned out even. It should be odd. No, but what I'm interested in is only the first bit. The first element, because I assume it is special. And it's still odd. Well, this is even. So there is a mistake somewhere. When mask is 3, this is 0, b equals 0, this is allowed, three times. This shouldn't be y, it should be mask. I decided that this is wrong. Apparently it's correct, and now I'm getting a correct answer. Why is it slow? Oh, because of that. Yeah. I still think that one line is wrong. Let's see, 64 should be the answer. And should it be so slow? Minus 64. Why modulo 2 am I using minus 1? Can somebody tell me? And why is it so slow? Because of printing. I print and it takes time. here we go. Works for the tests. Print minus answer. Great idea. Great idea. Well, didn't expect that. And what am I supposed to do with it? Why is this not used? Alright, because in inclusion exclusion I'm using -1 + 1, modulo 2, it doesn't matter. Okay, scary. Okay, I passed few tests with answers equal to 0. That doesn't mean much. Unsigned long, but I'm not here computing values bigger than 2 to the power 60, so signed long should be okay. Just in case though, I will copy this, which I couldn't do during a contest, but I can now. Yeah, I would now get information about overflows, if there are any. I still think that this didn't work for the first test. Div doesn't exist. This thing means that all numbers, they can be from 0 to 3. This bit in the first number needs to be 1, and my program claims that the number of ways modulo 2 is 8 choose 4, so it's even, meaning 0. But this trivial count, I think that I correctly here iterated triples such that they sum up to x, and there are 9 ways. Mask is 32-bit. Yes, that's okay, but you got me worried for a moment. Y is up to 2 to the power 20. So the things with binary operations, they are only int type, not long. Choose function operates with long. Let's see. This is 8. This is 4. 8 choose 4. This does make sense. If I ignore all the bits, so just everything is arbitrary, then wait, what was YA1? Oh, that was 1 if and only if. This is a subset. Let's check if that's true. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. All of them are odd. Yes, they are, because 3 is such a special case. Okay. I'm using Wacom drawing tablet. Or equals Y. Inclusion exclusion gets rid of that check. So by doing this, I'm iterating subsets of y, and for each of them I'm only allowing subsets of something. And free choose a1. This is supposed to check 1 or 0 or 1 whether a1, a2 and a3 are subsets. So this would be 9 choose x. X was what? X is 5. Which, by the way, would be 0. But we're counting cases where a1 has the 0th bit on. So here we have only 2 choose a1, and now the sum of them should be 4, not 5. Why is it 8 choose 4? Is my code, brute force code, correct? Let's modify it a little bit. For every j, for every k, nine. This output is correct, but I still think that part of it is wrong, part of what my program prints. What if the first number can be only 0 or 2, and they need to sum up to x minus 1? Even. So that's not equivalent. Why? Well, because of that, of course. Even. And why is that not equivalent? What if I say 1 and 3? Eight. So from 0 to 5, not to 3. Oh, this thing counts also bigger values. There can be 4 or 5. If I want to actually count what my program later sees, it should be up to 3. X is not 3. So even. Okay, my program works properly for this first test, but it's a very easy test because y is 3. Now I want to get something that is a counter test. Let's see. Let's create a brute force. I will test only using n equals 3. And return 0. Okay, now let's just try something else. 3, 5, 5. It worked. 3, 6, 5, 7. I will later make a for loop if I don't see it in a moment. If I don't find a mistake. 4, 0. Okay, that's a counter test, just a big one. 3, 7, 11. 3, 1, 11. 3, 1, 3. Okay, got a proper counter example. I wonder if maybe 1 doesn't work. For brute force, I need to also say, actually, brute force. For n equal to 1, x and y need to be equal for the answer to be non-trivial. That's wrong, right? No, XOR, yeah, that's fine. And this is wrong. Okay, so n equal to 1 is a counterexample. Actually, I wrote that here. Well, but also 3, 1, 3 is a counterexample. If sum should be 1 of one element, the bitwise OR cannot be 3. And this seems to be an issue with my... Wait a moment. Inclusion exclusion was important here. This is not modulo 2. This thing is outside of modulo 2. Do I need answer is equal to absolute value of the answer? What's going on? Okay, I might be confused, but if this works, then I'm submitting. Nope. Well, I actually didn't check if it works here. Doesn't work. Why did I submit? If mask is equal to y, so everything is allowed, this should be taken with +1. This seems okay. How could this be 64? Pop count is 18 and 11. Maybe I'm hitting some overflows. So it found something non-zero only for a mask with 11 bits on instead of 18. So the answer should be minus 64. But why didn't it find anything for other masks? And this is not fixable just by plus minus 1 here. This is another issue, I think. They compile with wall extra and so on. There is wall, but there isn't W extra. So W all yes, W extra no. And also not pedantic. I think I tried that before and it was annoying. All the warnings are annoying, I guess. This, what I'm compiling, includes overflow warnings. I'm not sure about 1 to some power. Maybe this is defined, maybe not. But normal overflows, yes, they are included. I'm stress testing this. Free is a counter test. Is there something smaller? Like 2 versus 3. Or 3 versus 2. No, 3 was the smaller counter test. And it does work for the sample test, right? No, it doesn't work for the big test. Oh, but I figured out it's because of some other reason, because of the accounts. Okay. Or, well... Wait a moment. Big guy. What am I doing wrong? Should I maybe, for every bit separately, do inclusion exclusion to know if this bit should be taken with 0 or 1. So should we here XOR? Yeah, I think that's it. Okay. Because the fact that for different masks I'm checking the parity, it doesn't mean that I should add or subtract. Everything just means flip. Yeah, okay. So what would make more sense here is first this thing, then investing some kind of parity, using a mask for that parity, and at the end saying only if parity, then answer plus equal this. And here I would not modify the answer. Here I would say parity XOR equal 1. Okay, got it. Well, that's crazy. I knew a solution and yet it took me an hour. I mean, of course, this first solution, it would be enough to here change plus to XOR, which makes sense if we're talking about things modulo 2. Okay, now quickly about the second solution, but do I want to go through that? Radeusz told me another solution today, so just very quickly about that. And I think Radeusz's code will match it, but it's up to you to find it. We still do inclusion exclusion, of course. And then we group, I think like I wanted to do it in my first solution, where we say this: if n equals 11, then we have a group of 8 equal elements, then 2 equal elements, then 1 equal element. And we do inclusion exclusion. So now 8 times I can do, let's say, anything, 0, anything, 0. Then 2 times I can do also the same thing, and 1 time I can also do the same thing. Of course, eventually I will iterate over like 1 bit here, so maybe let's say this is 1. Now, because this is multiplied by 8, I can just add 3 zeros here. This is multiplied by 2, so I should just add 1 0 at the end. This is multiplied by 1, so just like that. I need to now know the number of ways to fill question marks, so that the sum would be x. And I have here, every question mark is a power of 2 that I can use or not. This is just 2. I have a certain 2, then I have a possible 4, which is here. I have a possible 4, which is here. I have a possible 8, a possible 16, possible another 16, and so on. And we have this there, and now it needs to be equal to 0, to x, and I want to know the number of possibilities. 2 I can move to the other side. So I have the sum of a bunch of powers of 2 that I can use or not, and it needs to be equal to x minus 2. Now, is there an even number of ways to do it? There is this claim now that we can group those numbers together. If there is 4 and 4, because of symmetry, I can also replace them with 8. 2 8s I can also replace with 16. 2 16s I can replace with 32. Continue doing so unless you have... I'm doing something stupid. Okay, continue doing so unless you have something like separate numbers, let's say 16 plus 32 plus 128, and you want this to be equal to x minus 2, and you care about number of ways modulo 2, and that's possible if and only if this is, like, you can in binary form get this number from numbers on the left, or in other words, just like Lucas' theorem says, this needs to be overset of that. I think I want to implement it just in case. Well, why not? Number of solved problems doesn't matter, right? So it's more about learning. Basically the game of 2048, I guess, just without the dimensions. But that's maybe a good comparison. Like in number 2048, two same powers of 2 will transform into a bigger power of 2. And what's the time? I hope that I didn't mess up the beginning, because I didn't read the code. And this part, it's like, well, if it's 0, 1 or 1, 0, then obviously there are two ways. So it makes sense. But it seems easy, right? Like, we don't even use Lucas' theorem here, because we're just saying, is there a way using those powers of 2 to construct this number? Well, those powers of 2 are different, so represent that number in binary form and see if it's there or not. That's an interesting way to prove Lucas' theorem. Okay, let's code it. So we have here, go for bits that are on in n. Yeah, I want to implement it. That will be second solution. This again is bit in the first number. Then there is bit in n. Oh, and first we have inclusion exclusion. Again, I'm not sure if that goes first. I think it's safer to do it here. This seems slow. I think it will be 20 cubic. So I'm missing some step, unless we can do some preprocessing to make this faster. Wait. This, I'm stupid. If we have something like 4 plus 8, and I want to simplify it by getting those numbers together and saying that this will be a power of 2, I can just add those numbers together. Yeah. I'm dense sometimes. That's just 16. This process that I described, it's called adding numbers. What can be a name for a math operation that takes powers of 2 and then it merges them together, like in the game of 2048, so that eventually you will get a unique representation of the sum as powers of 2. Well, that's adding numbers together and looking at binary representation of the final sum. Okay. Sometimes I'm surprised by my own, maybe not stupidity, it's okay not to notice something, but it's funny to then realize that. Now if n and this bit is on, this means like we have, say, 8 equal elements, so we're looking at that. Now for everything with question marks here, which is just basically the mask represents that, I'm taking that. So sum plus equal mask shifted by j. I don't need those brackets, right? Because casting is first, then binary shifting. And now, if what is subset of what? If sum contains x minus this, but also on the left I should subtract it. And we here require this as well. That's an easier solution, isn't it? 10 minutes of implementation. There you go. It's also slower because here we have a for loop of size log of n. Earlier we didn't have that. Is actually my previous solution, was it log squared or just a single log? It was a single logarithm. Okay, that solution was faster. This one is slower, but you know, accepted is accepted. And it's tight, 1 second, and I got 700 milliseconds. Plus, there isn't much you can optimize here. Wait, I'm doing something stupid here. That's just, I'm going through bits of n, and if a bit is on, then I multiply that bit by mask. This is just n times mask. Huh. Okay, that's the same solution. I mean, sure, all correct solutions, they need to be equivalent. Well, that was interesting. If you add those powers together, you get mask multiplied by n. Yeah, because the sum 8 plus 2 plus 1, that's from definition 11. Rediscovering summation and multiplication. Exactly. Welcome to the stream, right? I wonder now if Radeusz realized that. 156, that's slow. Okay, he realized that, n times y. I wonder why this is significantly slower, but whatever. So 1 hour and a half in, and we are done with one problem that I only described how to solve because I solved it in the morning, and another problem that I knew a solution for. I just needed to implement it. So this is done, this is done, and now I need to choose from graph coloring, bracket, and scoreboard. I think that scoreboard is the most interesting. Bracket seems difficult, but I also saw, I saw a spoiler. I saw one tag on the right. Right now I hide it. Hid it. What's past form of hide? I hid it. But I know an important algorithm that needs to be used. And F1 graph coloring seems boring. Let's do scoreboard. And that will be the last problem today. Also, I counted that, including this problem from a moment ago, in the past few days, like past 1 week, I think that I solved 40 problems in Codeforces in past week. And it's not that they were all easy problems. On one hand, that's nice, I'm practicing. On the other hand, strong people, when they just participate in those same contests, they do the same number of problems just during a contest, while I instead need to spend 2 or 3 hours plus a few hours of solving and seeing solutions and then implementing, which is sad. Still, I shouldn't complain. Just from time to time, I perform well enough that I get to the finals or I win something. Okay, scoreboard. So we have here n problems that we need to solve. At least I'm solving them. It could be worse. I'm aware that I'm in 0.1% top people. I mean, less than that. But still, everybody will keep comparing themselves with somebody better. I wonder if now Tourist compares himself with his former self from maybe 3 years ago, if he used to practice more. Because Tourist used to just win everything, and now he doesn't. So does he feel bad? Is there now no single person who is happy with their overall performance? I'm using your template for debugging, and very nice, but I'm not understanding it. That's fine. You can change imię, which is a Polish word, to something else. Okay, now what do we have here? We have... I already spent 20 minutes on this problem. There is time, and we are given n linear functions, all of them decreasing. This is not a linear function. This is. And at every moment of time, at every second, like here, 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 I need to choose one of the functions and I get a score from that function. I need to maximize the total sum of values that I will get, and I cannot use the same function twice. Also, the function continues flat after getting to 0. So maybe what I should have done is this, and so on. So it's not that you will lose. You will get some value from every function. Here in the statement, they actually wrote something like a function will get you maximum of AI points, comma BI minus slope times time, but you can easily move AI outside of the function and then you will maximize with 0. And this is new BI prime, let's say. So this is what I drew is after some simple reduction. There are functions, linear functions, dropping down to 0, then being 0 forever. At every x, you need to choose one of the functions, the different one, and you need to, after n seconds, you need to maximize the total score. Here, maybe it's optimal first to choose the white one, then to choose the green one, then to choose, I'm guessing, blue or yellow, then to choose the other one, blue or yellow, and then to choose green. No, green was taken, so red. I claim that this is optimal here. And what I used here is the fact that usually the first that should be taken is the something with biggest slope, something that is very steep. White loses points a lot, so if you ever want to take white, you should do it at time 0. Unless something will drop to 0 and then you're not in a hurry. So for all, of course, if something drops to 0, then why bother taking it? It will give you 0 score after that transition from before. So we are actually ignoring those parts with 0, and just you have a possibility of taking something or not. If you don't do it until this moment, then you just get 0. And there is this trivial claim that we should sort by slope and in this order take them, but also for every function we have a possibility of just not taking them. Here's an example. Imagine something with something very steep here, but also very low, and at time 1 it will eventually drop down to 0. It's not beneficial to take low score here, and because of that delay everything else by 1 second or 1 minute. So sometimes you should drop things. And now, after you sort by slope, for every object you take it or not, and there will be some time that already passed, which gives us dp of I and j, where I is ID of a function that we're currently looking at after sorting by slopes, and j is how many things we already used, or in other words, that's the current time. And when you are at I time, then you have two possibilities: either skip, meaning move to dp of I plus 1 time, or take, which means move to dp of I plus 1 time plus 1. And if you decide to do it, you also increase your score by the function, this function. You don't even need to maximize with 0, because dynamic programming will figure out that it's not optimal. So here I can just say b of I minus time multiplied by slope. What slope? K. And you are at the end, the answer is max of dp of n, and here whatever. That's a trivial quadratic dp, and we want to optimize it. And the intuition says that, I mean, there are different dp optimization techniques, and the only hope for us to optimize it is if there are some properties that are maybe not trivial to observe. In particular, this function of time, so if for every dpi we look at different times and we want to know what is the current best thing that we could get, this might have some properties like being convex or concave. So, and it has nothing to do with the previous drawing. The previous drawing showed the input. This shows some abstract function. If we have a fixed I, so we already considered maybe 5 functions, and there is current state of dp. For every possible time, there is our dp value. If time 0, meaning we haven't used anything yet, then the score is 0. And then I'm guessing that the function looks like this. I mean, if you can use one object, it will give you a lot, and then it's diminishing returns. So every next unit of time gives you less and less. Eventually, it would give you negative contribution. Maybe we will just drop that. I didn't think about it much, but maybe this should be ignored, depending on what is easier to implement. Thank you for recent streaming. You're welcome. And I even looked at the beginning of the editorial to confirm to myself that indeed I'm going into a right direction. And yes, the editorial confirms that something is here convex or concave. During a competition, either I guess it or I implement a brute force to verify that on thousands of random tests. And like that also you can check if always the differences are decreasing. So what my claim is this, and that means convex. dp of I t plus 1 minus dp of I t is greater than that. That's what we are verifying. No, sorry, t plus 1. This means exactly that this height is bigger than that one, or equal. But for me, it's not enough, so I was stuck here. I didn't go further into editorial. I mean, I'm aware that this should be optimized. But for me, it's not enough. I think that I would want even the next level derivative to be monotonic. So not only I want this to be convex, I would want the derivative of this function to be convex or concave. Because if we look at transition, for fixed I, of course this, okay, there is this constant, and then there's slope, k. So for time equal to 0, this just increases by bi. Then for time equal to 1, it increases by bi minus ki, and so on. It keeps decreasing. But that can arbitrarily mix with those slopes unless we claim something stronger. So from this thing, the transition will be by just plus b here to some point. This is plus b. But from here, the transition can be is by plus b minus k. From here, it is plus b minus 2k. And from here, it's plus b minus 3k, and as well, it can now go down, I think. So what this problem is solvable if we can claim that some prefix, for some prefix, it's not optimal to use it, and for some suffix, it's optimal to use it, or the other way around, because then we'll do something equivalent to binary searching. But in my opinion, this can be mixed. And I can write a brute force to verify if this prefix suffix thing is true. But even if it turns out correct, I don't like how much I don't understand the nature of this problem. Another way to look at it is this. For every DP state, you will do this transition or this transition, right? Like one of them, we shouldn't say is better, but maybe we should look at transition backwards. For every state, it was created by some transition, skip or take. And now there is this crazy claim that maybe for small times, they are created thanks to skip transition, and for big times, they were created with take transitions. Because maybe for smaller time, skipping the most recent element was required to keep such a low time, because otherwise something else is better. And as I'm talking about it, it seems reasonable, right? If you have more time available so far, so if you had 50 functions and you are focusing on the most recent function, but you could only use 10 of them, because time is equivalent to how many functions you used among the previous functions. If you could use 10 out of 50, maybe you then use the most recent one. And if you used 20 out of 50, well, then it's even more reasonable to use that. On the other hand, with bigger time, every next function is more penalized. So maybe it's the other way around. Yeah, exactly. So we get bigger and bigger penalty. At time equal to infinity, we want to take it. I solved the problem using Zebi algorithm. Can I share it? You mean this problem? You can share a link to your submission. Is there somebody in the chat who knows a solution and can confirm what I'm talking about with those like going up and down? Is there some property that holds here? Or is it possible? Is my drawing possible or not? We want to maximize. I think here it's very frequent that this will be below, because already you found earlier something better, something with a bigger b. So those first few, it seems intuitive that there will be below, but also at infinity. So we hope that eventually we want to use it. Oh, so I'm saying that with big time there is big penalty, but on the other hand, previous elements had bigger penalty. Previous elements had bigger penalty. Interesting. So I'm better than them at being used here on the right. Okay. I'm starting to believe that starting from some point, I will always be better like that. I think just how to say that in English, cheated myself. I confused myself. I made myself think that something is incorrect, but it seems okay. Now, if I have some slopes, and I'm searching for this first point where something is optimal, should I use something like binary search? I think I need to use... Yeah, so we hope that this is binary search. We'll keep those slopes. With binary search we find this proper place, and here we will shift this part of the drawing up and right like this. New drawing. We will find a place where we should insert our new slope. Then we'll take everything here. We'll shift it like that. We'll add this new slope. Those slopes do not change. So it's like a set, but a set that allows us to do binary search with indices. I will first implement it using a vector. Don't take this into consideration. At the beginning I explained how I get rid of AI. Oh, and again in this, I'm not able to highlight a message. Can I highlight this thing? Yes, I can. But I cannot highlight your message. So again, a test. Okras, can you type again the same message? And regarding your question, I at the beginning explained how I can subtract AI from such a formula to get rid of it and to just say we are maximizing with 0. The second message worked. So what's the difference? This is just copy pasted. I guess that's just bug of that software. Well, if it's rare, that's fine. So some solution use play tree. Yes, this will be trip or BST. I don't really know how to implement trips. I will use BST because I know BST. Backticks break it. What's that? Oh, special characters, but Outcross copied the same message. So, this thing worked. The previous message with exactly the same thing, character by character, didn't work. So no, it's not about special characters. I think it's just software, breaking for a second from time to time and not registering message. I even have a theory. If I here refresh that, one occurrence of a message will disappear. Yeah, here we go. The software didn't register that previous message. And it's weird, I agree. Your new weird again didn't register, but that's because I refreshed chat. Okay, now do I remember how to implement BST and will this do the job? Yes. But it will take some time. First, vector solution. Certainly. We have HCPP, test cases. Everything will give me B and slope K. Those are just pairs. K, B, A. So now anyway plus equals A, and do that. This is how I'm getting rid of A. I'm subtracting lines, pushback, slope, and the starting point. Then sort decreasingly, right? By typing R begin, R end, I'm doing this decreasingly from biggest slopes. Wait. Yep, that works. And now I want to first, will I keep a vector of slopes? Yes. Is it true that everything is int here? Also yes, unless it's at the end. Okay, this is long. Initially it's empty, and it just means that there is 0 at the beginning with no slopes. Then for every line, right, I wanted to do tie. Should learn that. This is slope, comma, B. Does this compile? No. Okay. Out. So I should I ever use a word tie? Oh, I see. What about anti? anti is not needed. I want to find the first moment where it's better to use this. So for if this is at the end, or let's see, I will here lose b minus I times slope. If this or this is better, meaning bigger, then insert this here and break. At the end, I want to know the top point. First, let's just print dp. It should be positive values and then negative, and positive values plus anyway should be the answer. That's too big. The answer isn't so big. But it's decreasing at least. Unless I should just add everything, but yeah, that also doesn't make sense. This is 25, it's huge. I want to read into the second test then. The correct answer is 53. Well, it makes sense. From everything, here I take 1, 4, 3, that's 8, 9, 19. This is fine. Then what's the order? K and B. The second value is B. And do I start in time 0 or 1? 1. That means that we should, in my code at least, do this as well. Even anyway should be decreased by that. 2181. So I think that, right? No, that shouldn't. This is fine. Okay. Now this is 70, 81. We get 71, which suggests that the first minus 3 should be used. That would be very strange. What about that? 19, 25, no, 35, 45, 50, 56. Again, the next negative number should be used. Why? Around 4 billion. This is around 4 billion. And 120. $189. This is too big. I only can use those. So something seems to be wrong. How to decide when to look at the tutorial? When I'm stuck for a long time. That's it. As long as I'm investigating new ideas, what's the point of looking at the tutorial? Sometimes I want to just save time, but it's an educated decision. I want to test it for something very small. And I don't like how big all those tests are. So For now, let's say 1 test, 1 kBA. Slope is 1000, B is 5, A is 4. And let's implement this. Also, 99 is correct. 0. If I take it, do I lose 999? No. Why is that? Oh, so this is like doing 1, 0. And you're losing 999 indeed, if you take it after 1 second. Okay. Now, if I place that with 1 and this with 50, this should be 49, correct? And something more difficult. Slope 2, value 100. First, we should take this item because, no, this item because it has a higher slope. We will get 98 out of that. Then next, this 48. So this seems fine. Do you want to analyze this big test? I can implement the normal DP as well and just treat it as a brute force. Because here I tried immediately doing slopes. Maximize this state with just my value by skipping this one, and maximize that state with me plus b of I minus time times first. This should be valid brute force. $143. What's that test? Well, that's wrong. Missing end near B. No, here you don't need end. I mean, for speed purposes, sometimes you want to do it, but it doesn't matter if it's a single element. This thing here, ampersand here, was necessary because I wanted to modify A. Here it's optional for speed. I'm not adding anyway. And that's still incorrect. slope 1000, B50, A40. Oh, first one. 40, correct. 5, 50, 40. Should be 45. And here it should be 5. So it thought that it uses time equal to 2. Oh, because I'm already subtracting here. So this is enough, because I subtracted once there. Okay, we have a valid brute force. Now that helps, because I can get back to my smarter solution. And try smaller tests. I wanted to run them for into. And one of them didn't print anything. H doesn't print anything. But also it would be correct. So (2626). Done. Counter test. Now we need to simplify it. I'm trying to make a mistake to be bigger than 1 if possible, but I'm guessing that's because of the slope. Okay, now it's optimal to use bigger slope first, so after 1 second this will be 25, and this one after 2 seconds will be 46, and that's in total 71, which brute force claims. H 48 and 25, so the total is 73. 48. This at time 0 works. Oh, we need to those slopes, do they change as an extra? We first consider this guy, and it knows that the slope is 25, and that's cool. Then from 0 to 48, and we still claim 25, but this shouldn't be 25, this should be 23, so we actually need to decrease that slope. It's like modifying that, but k extra. I think that once we find this, all the slopes on the right, they need to be decreased by k, by the slope. Which I will explain in a moment. But that's bad. Okay, so the thing is, the reason why I needed to do it, I'm out of pages. Here's the situation. When we have our drawing tablet was tilted, or we have our function maybe here we realize that it's better to use the new item, the new thing, and we claim that then it's also optimal to use it anytime here in the suffix, but it actually won't be used as the second one. It will be used always after everything else. So if here I'm using something like b minus k as the formula, if I decide also from here to transition there, what will be used is b minus 3 times k. When I use it, so this difference here, this is b minus k. No, this was some old difference. It was dp of 1. dp1. This thing. This is dp1. Now in red, this is b minus k. And if from here you want to use it, you need to sadly use b minus 2k, versus here there would be dp2. And now the difference between this point and this point is not just dp1, it's dp1 minus k. So hence my minus k. And also similarly here we will apply b minus 3k. And again, if you compute the difference between two yellow points, it will be dp2 minus k, and so on. So not only I need to binary insert something in the middle as this kind of, let's say, linear function, I need to then modify the suffix like that. Well, it's fine, I guess. I will submit this just to get time limit exceeded, to confirm that I'm not doing something wrong. Wrong answer would be a reason for concern. Yeah, running on test 15, I will get time limit here. Yep, 16. Okay, and now BST can do that. I wonder if trip or linkat is easier. Now, can this be static? How can it be static? How do I always implement binary search tree, like self-balancing BST? Do I use pointers? I think so. Can I use this without pointers? Not really. And do I want to implement this today? Yes, I want to implement this today. Okay, let's go then. Do I need maxi function? No, this was needed for brute force. The BST that I usually use is called scapegoat tree. You can read about it online. Maybe even on my YouTube channel there is a video. And I'm not thinking about functionality. It needs to know the size also something like one element, rightmost element. Oh, so size will be related to index in some way, but also TMP greater than DP. I need to know, let's say, the last DP. Let's call it just DP, rightmost, because node can represent a lot of things below. This will be the last of them. Lazily, I need to be able to add something, so there will be lazy left child, right child, and maybe that's it. Then, most basic thing is searching for the element where we should insert this thing, something with the given slope and b. My BST always will either have both children or not, or I mean both are 0. And find, what should find do? Actually, it should modify. There is slope and b. At the end, I should insert minus infinity or something like that, so it would always be found. That might be a good trick. Then this is fine. So this should work, right? Yep. That simplifies the situation. If this is the leaf, then I found it, and I need to, just before, insert myself. At this position, I'm inserting that thing. I will copy this, paste it here for reference. Maybe else. I need to decide whether to go left or right. And for that, I will ask my left child if it will find something that is enough to kill that guy. Also, we need to pass the current index I. This is how many things on the left we already skipped, initially 0. So if left wants of this, then left find, else right. But we also skipped things on the left, so I'm grabbing left size for that. Now, do my subtree want to accept this line? That is true if I have below such an element that this is true. So I need to check if, well, I will just compute the TMP. That's b minus I plus the size minus 1, because the last element is in size minus 1 times slope. What am I doing? TMP is greater than what? Than dp. This is the rightmost. Okay, if this is the leaf, and still as a to-do I need to do balancing of that tree. First, when I implement it, it will be quadratic. If this is a leaf, I need to add a new left child, right child, and so on. But I can just build. Anyway, I need function for building. Oh, and lazy. For now I'm not using lazy. To do use in find. Or maybe how tests aren't strong enough. It's almost impossible that in a serious competition, solution is something like a trip or BST, and they don't create a test where everything is increasing or decreasing in some way. I'm sure that I would be able to create a test in 1 minute where this will break. So no, I'm sure I can bet that this code will first get time limit exceeded if I submit it. Okay, build. If values empty, then no, not values empty, if size is 1. Vlad, stop spamming with the same question. dp is that lazy 0. I think they should be null by default here, but I'm not sure what I'm rebuilding. Else we need to does that compile? Yeah. Left build with subvector from begin to middle. And to the right half, I'm passing the other half of the values. What else? Lazy is 0. Anyway, lazy is 0. So. And anyway, dp is just values.back. And anyway, also this is true. Am I done? Okay, in this case we build using value that is here right now, which is dp. But first, just before it, we need to insert this thing. Also, left equals null should be equivalent to size equal to 1. I can check that. If it fails, I know I did something wrong when creating trees. What am I building? I'm implementing self-balancing binary search tree. This particular version is called scapegoat tree. You can read about it in Wikipedia. It's a fun, it's a binary search tree, but scapegoat means if any node is not balanced, is heavily not balanced, it rebuilds everything below. Which seems stupid, but it works fast. This was always easier for me to understand than rotating nodes. So what are we inserting? We are just inserting that TMP. And TMP is simply this. Here size doesn't matter because size minus 1 is 0. Okay, we need to return. And while returning, everything that we skip on the right should be decreased by slope, including this one. So after I'm going left, we need to say this: right add minus slope. So I went left. On the right there is a suffix. Easy. Now, when we get anywhere, if leave, that's trivial, else I need to first push left add my lazy, right add my lazy, lazy is 0. Also, after I'm going left and right, I need to merge them, and merging them is just about, well, updating the size and the p, or just I can say merge. Lazy should be equal to 0 at this point. Okay, I'm using lazy. This is rightmost. Adding, leaving once. Merge. Okay, this is correct quadratic code, I think, and I hope. Initially, I want something with just one element. So there is a root, and I will just put values. On purpose, I'm not creating custom comparator. Custom constructor. This is convenient for some other reasons. The p is just this value. Lazy is 0 and then null. Slope and b and I. What I want to get first, I can run it to see if it doesn't break. Memory leaks are fine. I'm not clearing memory, so that's okay. Generally it's bad, but whatever. Difference from segment tree with lazy updates. BST is dynamic, meaning you can add new nodes. In a segment tree, you cannot create new nodes. You cannot just add new nodes like at the bottom on the left and on the left and on the left. In BST is more like a set. Saga solved in 14 minutes. So he won the competition, right? It was this one where Radeusz was winning, but he failed on sys tests. One problem. Well, if this works first try, then I'm doing okay. I will do it in below 1 hour. Print. I want to print the BST tree without affecting the lazy values, because I don't want to make this work or not work just because I'm printing. So instead of pushing lazy values, I will do this, where if this is a leaf, we print pushed plus dp. Else we go down, also pushing lazy values. Minus infinities. So nothing new is added. That's bad. We often run build on multiple values, including sometimes normal values, so it shouldn't be the case unless I'm not printing spaces. No, I am printing spaces. What's size of the tree at the end? If it's 2, then why do I see only one value? It should be more than 2. Does building work? I hope that this doesn't get destroyed in line 60. Mm. Root size is 2 and leaf is true. Something is wrong with isLeaf function. Okay, here we go. Return that size is 1. Now we get a lot of values. Let's remove those unnecessary lines. And let's compile without sanitizers. I don't care about the size. And now, did we see those values before? I don't know, maybe. Now I want to add them up. Anyway, and that works. I'm proud of myself. Of course, less proud because somebody solved it in 18 minutes, but proud. Now, I should get time limit exceeded because it's not self-balancing. And I don't care that I'm getting, wrong submissions. Well, we passed more tests. Good. Now, I would be pissed if I got accepted with this because it means bad tests, weak tests. Now, we need to make it actually into a scapegoat. For now, it's binary search tree, kind of. Just some kind of dynamic tree. I'm not sure about a proper name. No. When we exit from something, so we do merge, we should say this: if not balanced, then I will change print to maybe DFS. Values is DFS and build of values. That's the whole trick. That's the whole idea of a scapegoat tree, where first we have is balanced function, and I should run this only for non-leaves, let's say. Now if return left size left is smaller equal, I don't know, 2 times r plus 5 and the other way around. This means this tree, this subtree is balanced okay. And theoretically for best time complexity you should just put 1 here and there, but 5 is better constant factors. So if you see that some tree has 3 things on the left and 1 thing on the right, it's not yet worth rebuilding. If this, then the values push back, pushed plus dp. else run here and run there. Values. Print called DFS. And that should work. Making this stuff self-balancing seems like hella work. Not really, that's like the easiest part of this. Well, I messed something up, but it took me 3 minutes to add that. So making this self-balanced is not a big deal. Well, I messed something up and I made it slower. Unless it's just a constant factor? I don't think so. It's possible that never we run this, but let's see. Left size, right size. Sometimes we run that. Am I being stupid here? I'm now wondering if I messed it up. Doing this from the bottom, and that's what happens here, is not so efficient, but I think it still doesn't affect the time complexity. Don't pass values to build by value. Where is build? I mean, it shouldn't matter. And how do I avoid passing them by values? This seems to be a constant factor. Like n gets then split twice. This is n log n, and just I'm making space complexity n log n. If I do what you are suggesting with vector ampersand, then I cannot do that, because notice this is not an object. I can add some extra few lines. What I want to do first is I want to generate a big test to see what's going on. KBA. A is smaller than B. Okay, no. This infinite loop. Something is wrong with my input, right? Test cases. This seems to be quadratic. I'm doubling the data size and it gets more than 4 times slower. Hello, not so lazy. Yep, I messed it up. So it's not about constant factor. How could it happen that it's so heavily unbalanced? $5,000 versus 200. If I'm adding something below, then I immediately check that. This is impossible. No call to left add. No, because we are adding in a suffix. Also, adding should be independent from the time complexity. That thing is okay. What we are doing is we are finding some position and everywhere to the right of it, we increase. It would be the same in a segment tree if you wanted to find some special position I and add plus X everywhere to the right. The issue is like with the function is balanced. Two doesn't exceed twice R plus 5. R doesn't exceed twice L plus 5. What if I am more strict? Okay, so what if I just say R plus 3, L plus 3. Still, how does that happen? Should I use here or? No, it's balanced. Now it's balanced. No matter what, I run merge and I check that. Do I add nodes in any other scenario at the beginning? Find. Function find is able to mess up balance of my tree. What if I say here one more way? Okay, another approach. Rand modulo size. This is yet another version of scapegoat tree. The answer changed, right? Maybe not. Well, I will submit this, but this is suspicious. Oh, and run doesn't work in Codeforces. Do I need to rebalance all the tree? Whenever I see a place with big imbalance, then I fix that place. Huh. Well, it worked better than what I had a moment ago, so there is a bug. I think that the bug is in find function. Still worse than unbalanced 3x1 test. Yes, because maybe I'm spending time on something that is actually stupid or pointless. Wait, what? I don't run build. Build. When I see an imbalance, I run through that tree with DFS. And I didn't actually rebuild it. What an optimal BST. This line was missing. So when I see that there is like 1 node on the left, 5 nodes on the right, I collect the 6 nodes and I don't do anything with them. They are still there. Accepted. Yeah. I wonder if this is also good. This has a name. I don't know if this is called something like dynamite BST. So also, instead of caring about anything, you can always say this. If a subtree has size s, you can with probability 1 over s rebuild it. And the average time complexity expected is good. You wrote it, maybe it got deleted. Yeah, when I changed the style of doing something, I modified a few lines there. Like earlier, this looked differently. I didn't have DFS. I don't remember. So it's accepted. With randomized version, it's also accepted, but this first is better. And I believe that the diff from, let's see, from this code to this one should be just 1 line. I mean, here I added a few lines, but it's the same. No, wait. Oh no, it was to this code. So this was not balancing. Then in 3 minutes I corrected to this thing. And then we required 1 more line. So let's see. This thing. Compare. The comments, yeah, that's only that line. Because that got removed. I see I tried difference 5, whatever. So age solved. Editorial, I'm guessing, will describe something similar. So they are saying, I didn't read those formulas, that's a formal proof. So I got here that it's convex. Use the trip to maintain this sequence, which might be called the slope trick. Well, I'm interested in this part of the solution. And still, I would appreciate separate comment discussion for every problem. Otherwise, it's difficult to find something. Okay, so in the past week, I solved, I think, 41 problems. I will update. Oh, why is my stream not here? So was it down the whole time in Codeforces? Oh, that's a pity. Because Codeforces users are the main audience. Maybe I was like 1 minute late, but I thought it was like this. It was displayed at the beginning. Where's my blog post? Here. So now solved, solved and solved. What is left is those two. I'll maybe for clarity remove that. And I don't want to refresh the post. Cool. Dun, dun, dun. Okay, I'm reading the chat now. Am I planning to participate in live contests? Yes. But I need to have time. Also, I don't like 3-hour contests in Codeforces. And the last Division 1 round, the normal 2-hour contest without mixing with easy Division 2 problems was, I think, 4 months ago. So Codeforces holds normal Division 1 and separate Division 2 contest only once every few months. And it's difficult to get one. And like last Sunday, which was yesterday, I couldn't participate because I was busy during the round. I haven't seen a video on this. You mean something like this BST? Yeah, you need to know something, some BST or some trip, I think. Trip is randomized BST. I believe that. The stream was nice. I'm happy to hear that. It was difficult, of course, so it wasn't for everybody. I need to remember to take a look in the middle if the stream is running. So also tell me, if you are watching my stream and it's of Codeforces problems, and during a stream you don't see this on the right side of Codeforces, tell me. So this is profile of what? Of somebody who described the technique. Oh, so he's using Python. Okay, never mind then. I thought that it's something related to BST. Hello, whoops. When is it time to learn strategies and algos? Once you get, during a contest, you get to problems that require something, this is a time to learn it. You can lazily learn things whenever you encounter them in a real contest. But also Codeforces shouldn't be your only platform. Codeforces is too mathy. Were you on a break last year? Not exactly a break. I was just doing other things. My comment on joining Google? Well, right now I'm sure Google doesn't hire so much as a few years ago. But yeah, somewhere in my frequently asked questions I talked about it, right? That's why would I join Google? Which competitive programmers I look up to? People in the top are smart. It's not that I look up to something in particular. I know people from Poland better, of course. For example, Radeusz is a beast. He can, as a single person, he will win some ICPC contests. Of course, he's strong. Okay, stream is over. We solved 3 problems, which is less than I hoped so. I hoped to, but that's fine. I think there will be one more stream this week, possibly on Wednesday. I'm looking at my calendar. Yeah, Wednesday, maybe Thursday, but most likely Wednesday. And I don't know, maybe I will solve those 2 problems, but I hope to do it until then, just outside of streams. Maybe it will be a new contest. And that's it for this week, because on weekend there is a competition in Poland I'm participating in, so I will be out of Warsaw. You can, for example, in Twitch and maybe also on YouTube, there is a link to my calendar if you want to import my calendar of streams into your Google Calendar, but I only put something there once I am certain about the stream, and right now, I don't know if it will be Wednesday. Thank you all, everybody, for watching. Remember to also solve your problems. What I was doing for the past few days, it should show you how you should practice. I participated in few contests, virtually usually, but I tried to solve the difficult problems anyway. And right now, because solving easy problems isn't very educational. So right now I have here 8 out of 9, 8 out of 9, 5 out of 6, 5 out of 7, and I want to solve one more, 6 out of 8, and I want to solve one more. Plus there was an ICPC competition I also did. Have a good evening.